My name is Taskin Ucpinar. I'm the Dent TSC chair. I work for Amazon. And I should thank Amazon for letting us be a participant on the Dent open source community. I'm assuming you guys are all familiar, at least heard of Dent. So I'm not going to go into the details of the edge computing or edge networking, the enterprise deployment, disaggregated networking. I'm just going to go ahead and skip all those details. I'll start with the elephant in the room. I've been told that I have to talk about AI during this presentation, like everybody else. AI. And that's the only mention we're going to make, because like networking on this subject, on that, we don't do AI. However, we do a lot about networking on the disaggregated networks, edge deployments. During this presentation, I'm going to go ahead and briefly talk about what we did last year, focus on the quality and stability improvements we did, and I'm going to talk about Dent 4.0 and beyond. I'm going to go ahead and say Dent 4.0, but in reality, 4.x is a better description of what we are going to be releasing this year. And then I'll pause for answering questions. The 2023, last year, we had a few releases. We call them Cynthia. By the way, all these names are coming from a well-known book. If you're wondering about it, I think Cynthia is mentioned at the edge of the restaurant, I think, on a well-known book series. Cynthia did have 3 releases. We call them 3.x. It included a bunch of features, new features, as well as a really focused effort on stability and deployability questions. It's not just making the OS available for the networking, but how do we make sure that it is really deployable and usable in real stores, real environments. 3.0, it came out as in March. It included a bunch of features. I'm not going to go through the list of features, but in general, how do we control the deployment? How do we make sure that the communications are secure? The network data flow is controllable, and only the allowed players can access the data. We updated, obviously, the kernel, and we introduced a more structured testing framework for the Dent OS. The full testing of some of the features were not fully vetted with our new framework, so we just call them early access features. However, as a follow-up, in Dent 3.1 release, which came about 3 months later, we added a large number of test suites. The total number of test suites that we added is 240, with lots of tests in them. And also, we vetted the features that was made available as an early access in the previous release. And some notable features is .1x, QoS, IPv6, IGMP snooping, egress policy. These are all very enterprise-centric features that's made available to the community. We also follow up with the Dent 3.2 release. The Debian 10 was updated. We added support for virtual Dent OS, so you don't have to go ahead and use the physical devices. You can do the control plane and some of the data plane functionality through Dent. And I'll explain why this is a big difference. It's not just the control plane access for the virtual Dent. It enables the data network flow as well. Certain cases, we enabled our VRF, and also we added, again, more and more test features. These are all targeting for the fact that we are deploying these new features in the actual Amazon stores, for example. They are being used by the actual customers. Very brief description. If you guys have questions, I can answer the previous year's achievements, but I think we should focus on the Dent v4. We're calling it Deep Top. There are very drastic, big, huge architectural changes. We made improvements, and also we are working on future-looking features, forward-looking features. And obviously, we are adding, to a degree, new protocol support, but as it is today for the enterprise features that we are supporting, we feel fairly comfortable that this is usable, it is available today. Before we get into the details of like what the features we're working on, I want to make sure that we are all on the same page. We do love switchDev. It does make a very compelling argument for our OS. It doesn't include proprietary components. It is integrated directly with the Linux kernel. So if you want to go ahead and deploy Dent on a switch, and if you want to go ahead and set up the BGP, you use FRR. You don't change the utility at all. FRR is a standard release FRR that's included in the Dent. So if you're setting up the BGP, you go to what you call FRR. You set up the data flows, what you call neighborhoods. All the calls go into the kernel, just like any other Linux distribution. At the kernel, we intercept those what you call setups. Instead of sending them to NIC, we send it to an ASIC supported by, let's say, Marvell or Broadcom or any other ASIC vendor. That way, you can just go ahead and deploy the Dent on switches, cameras, servers, anything you want, and still use the same utilities. We think that it reduces the management cost, in introducing a new data plane configuration utility. You don't need. If you know how to configure FRR, BGP on Linux, you can do it with the switches. So you use standard applications. No need to modify existing applications. FRR is still the same FRR. No need to write new applications. If you're going to write a new application, it's going to be an application for Linux. It is not going to be specific for the ASIC. And that is the big differentiator we have. You can go ahead and take the same application. It is going to talk to the kernel at the end. And that kernel transition that we do with the switchDev is going to handle the networking setup. That way, you don't really need an abstraction layer. We do like switchDev. However, if you're going to go ahead and add a new feature, you have to make Linux kernel modifications. I'm not criticizing the kernel process, like how do you commit code into the kernel, but it is a very long, involved step. You have to go through multiple code reviews. You have to sometimes to modify the implementation that was agreed upon a month before. The kernel community is kernel community controls what's going into the kernel very tightly, which is they should. It is very important because it becomes available for the entire Linux world. So it's not just whatever the changes we are making. Potentially, it may not just affect the networking. It will affect everything else. So we go through that process, and that process can take a little while sometimes. It's definitely longer than an application implementation. When you're doing an application implementation on the user mode, it's fairly straightforward. You don't affect anybody else. You affect that box only. Not when you're doing the kernel, especially if you don't want to maintain the kernel changes yourself, which we don't because we're upstreaming all the changes to the kernel, and the features becomes available to the whole community. That affects the time to market considerations. Kernel versus application layer modifications are different. There's only a limited number of people who can make the kernel changes. I'm not saying they're any better or worse than application or kernel development, but at the end of the day, somebody has to make that change. And the number of people who can make kernel changes is two orders of magnitude less than application programs. So you need special kernel development expertise. When you're implementing a new feature out of the body, for example, if you want to implement a new feature that FRR doesn't support yet, you may need to go ahead and make that change on the kernel. And it can take a little while. So overall, user space programming is simple. It's much simpler. You're still using the stock Linux distribution. However, when you're doing the application, the programming, you can just go ahead and implement those features in a faster way, in a much faster way. Yes, there's always backward compatibility considerations when you're using the kernel, an application that you implement. You don't care about backward compatibility because kernel is going to support it. So when the kernel gets updated, there's backward compatibility assured by the kernel community, Linux kernel community. So your application is still going to work. Whereas when you're adding the, updating the application, implementing the features to the application, there's no guarantee that the next version of the Linux distribution is going to be, your application is going to work on the next distribution. It's just the nature of the beast. But both approaches have pluses and minuses. We do like the switchDev for another reason, and this is the last point here. It really requires very little resource requirements. The memory it requires is, in the last release, for example, switchDev, it's only like 52 kilobytes on top of what the existing Linux distribution is, Dent distribution. So you can run a Dent-based OS on a switch as little as 2 gigabytes of memory. Like on our current, most of our current devices, we have at least 4 gigabytes, but we just want to make sure that everything is kosher and maybe we have room to expand. But in itself, since this is just a simple Linux distribution with the kernel enhancements, the resource requirements for the Dent is very, very little. So what's the problem? How do we solve this issue? Like, we don't want to go ahead and be depending only on the kernel, and we want to go ahead and extend the availability of the application space, but still keep the original promise that this is going to be small, this is going to be very flexible. The solution that we came up with it's a combination of two worlds. We think that it's the best of the two worlds. One is, yes, switchDev is available, but there's another abstraction layer available. It's called SCI. It's used by the other operating systems. It's supported by a large number of vendors, ODMs and ASIC vendors. So can we use SCI, OCP SCI, that would enable the customers, the users, to use user space APIs without going to the kernel, so that they can do the implementation in a faster way, faster to market at a cost of high resource requirements, maybe, but also enable a larger number of ASIC vendors. If you look at the switchDev ASIC vendors, it's fairly limited. But if you look at the OCP SCI-based vendors, well, you have solutions from Marvell, Broadcom, Mellanox, now it's NVIDIA, Cisco, Juniper, you name it. There's a large number. And these SCI libraries are available publicly to be downloaded so that it can be incorporated into an OS. So we thought, why don't we just go ahead and merge the SCI and switchDev together and provide the solution in a way the community can choose to use switchDev or SCI without giving up on one or the other. So we are keeping the existing Dent features, processes. So if you are using FRR, you're still going to go ahead and use FRR. Keep the Linux kernel and switchDev drivers. They are still available. That will enable us to use the native Linux applications as they are, but also implement a transition layer between the switchDev and SCI, so that the workflow still goes through the kernel and somehow directed to the SCI if we choose to, so that the engineers can, or the customers or users can use the SCI-based implementation to implement SCI-based distribution to implement a network OS. While we are maintaining the hardware agnostic, while we are keeping the hardware agnostic behavior of the Dent. I don't want to go into a lot of the details of how the integration done between the SCI and the switchDev, but you can do it in 3 different ways. In one way, you're still using the normal FRR application. You're still using the IF up-down standard Linux distribution components packages. The calls still go to the kernel. In the kernel, we intercept. We send it to a switch manager, what we call, which literally glues the, the Dent to a SI API call. So the switch manager does a API transition from switchDev API to SI API. As far as the users are concerned, they don't see it. The transition is automatically done. So that the polling, synchronization, bridging, like the API transitions are all automatically handled by the, this switch manager implementation. This is one way of implementing. So you can still keep the implementation as it is, but link it with SI from Broadcom or Mellanox or NVIDIA, and your Dent is just going to work with that target, with the existing all open source OCP open source hardware. This is the easiest method of integrating, but you still do have the dependency on what SI supports or what the applications that the kernel distribution, Linux distribution supports. If you want to go ahead and extend it, there are other ways. The SI API is available for the users, for the developers, for the partners. So on that, you can write your own application that directly calls the SI API, because the SI APIs are available through the OCPs, repositories. You can download the SI API, call the SI APIs directly, and that will support it. Obviously, in these cases, the transition from the kernel to the application or the ASIC is not going to be controlled by the Dent itself. You're choosing to implement your own application to call the SI API and implement whatever the feature that you want to implement. It is available. This way, what we think is you can implement the functions in kernel. You can implement the functions that you need in application layer, or you just use the available applications for the Linux itself. The transition happens on the backend for you. So you can use 3 different ways on how you're going to integrate and communicate with the networking layer. If you have any questions, please do interrupt me. I'm okay. I'll try to answer them. This is the biggest feature we've been working on. Right now, it's in final review phases. We're about to upstream the common SI platform implementation to the community. It's going to be available for everybody. You can go to the GitHub and download it. That is the biggest feature that we are working on for this release. But there are additional other features. For example, the Yocto migration. We want our packages as customizable, as small as possible, and there should be a roadmap for maintaining a long-term distribution. ONL-based implementation that we have today, it's kind of like getting dormant. We want to go ahead and implement the features, but make changes on the build infrastructure, but it is a lot of work if you're going to go ahead and maintain it by yourself. Whereas if you have a more modern package management or a distribution manager, Yocto is there. It does support the legacy devices. At the same time, we also support the Edge Gateway. That is a Marvell-based ASIC based on SI implementation. So we are going to be adding the support for the Yocto-based builds. Again, it's on the final review phases. We are updating the kernel to, as of today, to 6.6. I do believe that we are going to update the kernel by the end of the year again to move to an LTS release. Also, to get some of the new features that we are also contributing on the PoE++ side, on the kernel-based implementation. I'll talk to you on that in a bit. And final big piece that we are adding is we do have PoE and PoE++ support on a limited base. We are increasing the support that we have in the kernel space as well. And also we are changing the utilities so that we do support LLDP, for example. And I don't know if you guys are familiar with the enterprise work, deployments. One of the biggest costs that you're going to incur is You have to go down provide power to your devices. You have to go down provide networking for your devices. That's 2 cables. If you can go ahead and get rid of one of the cables and provide the power over Ethernet, that's PoE, you're getting rid of at least one of the cables. You don't have to go down to deal with the deployment issues. You don't have to go down to do the scheduling conflicts that you're going to see with the contractors going in and doing 2 wires. You're going to do it in 1. Also, when you're doing the LLDP, there's a negotiation protocol for the PoE. When your device is connected, it may require 60 watts, for example, to boot up and initialize everything. But on the steady state, it may reduce the power usage to 30 watts, 25 watts. And this negotiating protocol is going to be integrated into the Dent OS as well, so that we can save on the power. We can serialize, for example, device boot ups, so that we can reduce the cost by not including a full-size, power supply, but only what's necessary during the steady-state running of the store or your deployment. Also, we partnered with the LF. We do appreciate LF's contribution on this one. They let us get 2 interns. We are massively modifying our documentation. They have been working on this for the last close to 5 months. We are adding more user stories. We are adding user cases. We are documenting the differences between VMs and non-VMs, physical devices, so that when a customer or a new user comes in, there is a tested, verified documentation available for, I'm not going to say all, but majority of the networking features. So I would really recommend you guys to go take a look at our documentation page. It has been improved like really drastically. Going forward, okay, this was the first release for the 4.0 or 4.x, and the Common Sci platform is supporting the Broadcom, Marvell. But going forward, well, the same type of devices, except that not using Marvell, using Broadcom, can be made available. And that's what the next release is going to be focusing on. We are going to add more devices support with Broadcom. So out of the gateway, you're going to be able to go ahead and get the device or the builds out from our community pages for targeting deployments for Marvell and Broadcom devices. We think that it's going, like having this selectivity between the 2 different vendors gives you the options, cost, supportability, etc. We talked about the Yocto. Yes, we are supporting the Yocto with the 4.0 release, but why do we stop at just Dent? That's the idea that we've been working on. Actually, the project has been approved today, this morning. We want to go ahead and share what we have on the Dent community with the broader OCP community. The idea is to implement the Yocto base layer implementation, so that it can be used by the Dent community, so that it can be used by the OCP community, and it can be verified, for example, for Sonic. And that's one of the goals that we've been working with the OCP community. How do we make sure that the base BSP package is reusable, not just by Dent, but other OSs as well? So that we have a simple, very maintainable, widely used Yocto distribution that you should build on top of it, instead of everybody going and implementing their own build infrastructure. We've also engaged with the kernel community. We are working on the current our current implementation for PoE is user mode applications. We are moving all that functionality into a PoE in kernel-based implementation. The first commit has went through. There are 5 stages. The first one is done. That's the hardest one. The basic infrastructure has been integrated into kernel 6.10. As the remaining 4 milestones are reached, we are going to have full functionality, including LLDP. That's already controllable through the Linux, standard Linux applications, instead of having our own application. Again, so that we can enable the rest of the communities, the Linux world, to support the PoE itself. One of the issues that we see during the deployments, you need to debug. And when you have issues with the, no, I shouldn't say issues, when you have debugging challenges in the field, gathering data for the kernel-based issues is challenging. So what we are doing is we are making changes for the deployments so that you can get more logs, you can get crash dumps at your leisure. You're going to be able to get more debug data. Additional items that we are looking at is firmware updater. Everybody here is familiar with the updates in the fields. My background is in ODM world. There are some devices that are that includes 19 firmware packages. A lot of you guys don't know that you get a single firmware package, but you update all the peripherals that's connected to the I2C, and that number can be high. We are looking into how do we provide a framework so that the ODMs can provide the tools that the framework can run and update the firmware in the field. And one last item we're focusing on is the .1x. We do have .1x support in the current release. We'd like to go ahead and include the features that has been tested to a wider coverage so that we can address more use cases. Right now, it's only like a couple of use cases has been verified. Couple is a lot, don't get me wrong, but we want to be able to go ahead and increase the coverage so that the .1x adaptation is more. There are additional features we're looking at, like MCLeg, MSTP, etc. Those are on our backlog. And I've listed some of these here. All right. I'm rushing. Sorry, I got the card. We're running out of time. Some of the additional items that are on our backlog, we talked about the PoE kernel implementation. It is being, currently being implemented. If it makes it to the kernel release 7.0, we'll use it. Otherwise, maybe we'll use it after the 7.0 release. There are features that we would really like to go ahead and implement for easier deployability, like dual port partitioning. We want to be able to go ahead and deploy on one partition while the second partition is active and running, and just switch the partitions active to passive, so that we can minimize the in-place update effects. Initial indication says a simple reboot is going to be able to go ahead and handle all the update issues in a very short time. Component upgrades is we're looking at right now. Just like the rest of the industry, the deployment for the Dent is you get a full package, just like Sonic. You get a full package. Not a single customer is happy about this. When you're updating the whole OS, it takes a huge amount of testing effort, especially addressing for the security-related issues. We'd like to be able to go ahead and update only the packages that's necessary. Obviously, that will include ZTP and even OpenConfig support, so that we can figure out what needs to be configured, what needs to be updated, how do we zero-touch provision the new features. There are some features that we've talked about, like multicast routing. I have to admit, I don't know what it means. We know we need to go ahead and support multicast routing. We need to go ahead and come up with solid use cases to finalize this is what the multicast routing is going to support. It's in our backlog. I know I rushed because we're running out of time. I've put the list of some useful links here. Our website is dent.dev. It's an open source development platform. You can go ahead and look at the repository. We have every source code. We don't have anything proprietary. You're going to be able to access everything that we have. And if you need help, you can just go ahead and send a message out to TSC. List.dev is our email address. And you can directly contact me. I can't promise 24 hours, but I can promise very close to it. If you have questions, please let us know. We are here to help and answer your questions.
Just one question. Do you ship any specific kernel
Yes and yes. Our goal is never to implement our own kernel changes that we keep as a proprietary change. However, there's always a gap between when we start doing the PR and when the kernel community accepts it, and that can go to up to like 6 months. This is true. And sometimes you go through 4 or 5 iterations and update the kernel before you can finally upstream. Our goal is to upstream everything, but most up-to-date code with the PRs are available through the Dent repository. Please?
This is the first time I'm hearing about Dent, so I apologize if this was asked before. Dent versus Sonic, how do you see the evolution? Because some of the features like you have been requested for Sonic, and most of the features you had in the last 2 slides are there today in Sonic. Is there a duplication of that product? How do you see the evolution moving forward?
This question actually comes up, and I try to answer it in 2 different ways. One distinguishing feature is Sonic has started from the DCs, where lots of memory, lots of computing power, really high-speed connections is available, and it is trying. I shouldn't say trying. It is slowly going down in to the enterprise market. Dent started from the enterprise deployments, and it's going towards up. And there is definitely a certain, what do you call, intersection where both OSs do support the same. However, there are definite, like very glaring, huge differences in the philosophy. In our case, we assume that the device has to be very small, it's very manageable, it needs to use as little as resource as possible, because lots of customers on the enterprise world, they don't want to go ahead and deploy a 400 gig device on a small store, right? On a Starbucks. So our devices are very, very cheap. They are very, very small. Just to give you an idea, like we have devices that support 48 ports with lots of, with a COMI edition, with a Wi-Fi, with an LTE card, supporting 1600 watt PoE devices, and they are under like $900. So our focus is make the features available as quickly as possible without requiring any new learning. So if you're going to go ahead and deploy a Dent solution and you want to go ahead and support cameras, Dent is going to work on the camera, but you're still going to use the same standard Linux application to modify and control it. You don't need you don't have a separate, it's not even a need, you don't have a separate command line for Dent. So if you're deploying it on a server, you're going to go ahead and use IF up down. If you're deploying it to a switch, you're going to use IF up down. They are standard utilities. That makes your life for managing the devices much, much easier. And it's always, always backward compatible. Unless Linux breaks the backward compatibility. It does happen, but it is much less. I'll give you the example. If you look at the Sonic's release notes, they always make it a point that a new release is not backward compatible. It never is. For us, when you're deploying the Dent version 1, 2, 3, 4, you're guaranteed to have backward compatibility. So our life, our customer's life, our user's life is much easier. There are advantages for Sonic as well. I mean, they do support 1.6 terabyte devices. We don't. We don't see a need for it. But including the SI with the upcoming release, if a user wants to go ahead and download a SI package from Broadcom to use on a, I don't know, Jericho chip, you can, or a Qumran chip, you can. Dent will support it as long as there's a SI that supports that architecture. And you don't have to change anything in the OS or the command line. I think that's the biggest differentiator. Mm-hmm. Any more questions? I'm getting the flag on here, run out of time. Please do get in touch with us. You're more than welcome to dive into the TSC meetings. It's an open source community. We welcome all the future feedback that we receive from the user base. All right. Thank you for everyone to